I've seen a lot about transformers during the past 6 or 7 years, right? So, you know what powers the transformers? You know what's the heart of transformers, which makes it a big success in terms of model architecture, right? So we'll see that. We all know like embedding is nothing but an input, right? You transform your features into an embedding and you supply that as an input to the transformers, right? And something magic happens to this embedding which makes it more powerful representation. We call it contextual embedding. Now let's see how what powers this. Yeah, so basically, your tokens or the input you supply to a transformer, be it encoder or decoder, right? It passes through a series of these layers. So your input just it gets can be used as a query Q value, right? So query. So just assume that a sentence could be one of the token in the sentence could be a query, and all the tokens in that sentence could be a key, right? So this too goes into a matrix multiplication, which is nothing but a dot product between the embeddings of each of these, right? So basically embeddings of a single token, which is a query, versus all the tokens. We take a dot product of this, and then the scaling. Scaling is important here because uh, all this vanishing gradient problems can happen when we have a larger magnitude of weights in the higher layers, right? So in order to prevent or minimize this risk, we do a scaling of the multiplied or the dot product values, and this is usually done via the so the scaling factor here is nothing but the square root of the embedding dimension, right? So if your transformer size is of some 68 dimension, then you take a square root of that and scale the dot product or the matrix multiplication value by this. Then comes the softmax layer. Softmax is also a critical because the distribution of the values here can be ranging from any, it could be of any value, and it can range between minus infinity to infinity. So we need to squeeze this into a range of 0 to 1 so that in the upper layer it can be easily used as a scaling factor for the value, right? So basically you can just multiply the values with this attention weights. This will give so you can easily understand like what portion of the tokens I need to give importance, right? So that's the purpose of softmax. So these are basically nothing but attention weights, right? And then you do a final multiplication with the value. This will give you a view on what specific portion of the sentence or the tokens I need to focus on in order to have a better context. And that sums up. So this is just a visual guide on what's happening, right? KQV, it's nothing but a map you create, and value is the raw value you need to find the context on, and you multiply both this to get a uh, you know basically a multiplication of this gives you the clear picture without the background. Thank you.